Example 6. Given that the remainder is x plus 2, when the polynomial x cubed plus 5x squared plus ax plus b is divided by x squared minus 3x plus 2, we want to determine the values of a and b. So this question is actually quite tricky, and there are a number of ways of approaching it, okay? One way is to actually set out polynomial long division, okay? So take the cubic divided by x squared minus 3x plus 2, right? And make sure that when we do the polynomial long division process, that the remainder actually turns out to be equals to x plus 2, okay? So that's going to be one way. Or there's an alternative method, which is to examine this polynomial, okay, as two different expressions, and then look at the left, look at the right, in order to deduce the values of a and b. So what do I mean by that? Let's say we've got x cubed, right, plus 5x squared plus ax plus b. So this is our polynomial. And we know that we can take this polynomial and we can rewrite it as the divisor, which is x squared minus 3x plus 2, times the quotient plus the remainder, which is x plus 2. We know that these two expressions are equals to each other for all values of x. So if I sub an x value into the left, right, that's going to be exactly the same as if I sub the same x value into the right. So what does that mean? If I take a look at the right hand side, okay, the x squared minus 3x plus 2 can be factorized into x minus 1 times x minus 2 times qx plus x plus 2. So when we take a look at this expression, okay, the biggest problem is that we don't really know what qx is, okay? But it doesn't really matter because we can get around working with qx by using carefully chosen values of x. For example, if we consider x equals to 1, subbing x equals to 1 into both sides, right, is going to effectively eliminate qx because we've got 1 minus 1, which is 0. So 0 times anything that comes afterwards, okay, no matter what its value, is always going to be 0. So that means that if I use x equals to 1, I don't have to work with qx, right? Similarly, I can use x equals to 2, right? If I use x equals to 2, you can see that 2 minus 2, the second factor here, becomes 0, okay? And the product of the whole thing, once again, becomes 0, and I don't have to work with qx either, okay? So in other words, if I let x equals to 1, right? If I let x equals to 1, the left-hand side is going to be 1 plus 5 plus a plus b is equals to, and then the right-hand side, I've got 1 minus 1, okay, which is 0, times anything afterwards, that's just going to be 0, plus 1 plus 2, which is 3. So what this tells me straight away is a plus b is equals to 3 minus 6, which is negative 3. That's great, right? We've got some condition. We want to find a and b, right? So while a plus b equals to negative 3 doesn't tell me what a and b actually are, you guys can see that I've got a condition connecting a and b together. If we try the second x value that I mentioned, right? If we let x equals to 2, the left, we're looking at 8 plus 20 plus 2a plus b is equals to 2 minus 1 times 2 minus 2 times the quotient evaluated at x equals to 2, right? That's just going to be 0 plus 2 plus 2, which is 4, right? What we have here is now just going to be 2a plus b is equals to 4 minus 28, right? And 4 minus 28 is just equals to negative 24, right? So that's how we get the 2a plus b is equals to negative 24. And you guys can see that I can call this equation 1 and I can call this equation 2. And now we can solve these two simultaneously, right? So if we check that out, so we know that equation 1, okay, is given by a plus b is equals to negative 3. And equation 2 is given by 2a plus b is equals to negative 24. So if I take equation 2 minus equation 1, that's going to give us a is equals to negative 21, right? So 2a minus a is a, the b subtract away, minus 24 minus 3 is minus 24 plus 3, which is negative 21. Substitute this back into either equation. So I'll sub it back into 1. So I get negative 21 plus b is equals to negative 3. So b is negative 3 plus 21, which is 18, right? So that's essentially how we can find the values of a and b, right? By considering this particular identity. And I personally think that this is probably the easiest way out of this, because alternatively, right, if I demonstrate this again, the first approach that we said was if we actually take the polynomial x cubed plus 5x squared plus ax plus b, right? We consider this polynomial and we divide by x squared minus 3x plus 2. And this will actually turn out to be quite messy, right? Because if I do this polynomial long division, I need to ensure that my remainder, okay, turns out to be x plus 2. So I need to adjust for a and b such that the remainder becomes this expression here. So if I check this out, right, x goes to the top. So I've got x cubed minus 3x squared plus 2x. So right now what I've got is 8x squared plus ax minus 2x. That's going to be a minus 2 times x plus b, right? And then we plus 8 in the quotient. So that's going to give us 8x squared minus 24x plus 16, right? And this thing here, okay, needs to become x plus 2. But right now, okay, 8x squared minus 8x squared cancels away. A minus 2 minus 24, that's going to be a minus 2 plus 24. So we've got a plus 22, lots of x. B minus 16 is going to be plus b minus 16, right? So once we've got this, we say a plus 22 must be equals to 1, and b minus 16 must be equals to 2. So that's essentially how you're going to get a is equals to negative 21, and b is 2 plus 16, which is 18, right? Exactly the same as what we've got previously, but this process, okay, I mean, it's not too bad when you guys look at my working out, but when we're doing it, the long division process with these unknowns sometimes could get a little bit trickier, okay, especially if we've got difference in signs everywhere and it's easy to make mistakes, right? Whereas if we consider this identity, it's pretty easy to just take different values of x, sub it in, and kind of think about it as simple equations straight away, right? But anyways, both approaches work fine. So as long as you understand one, you should be okay, right? So this is what we've got for example 6.